Again, here's a mechanical motion question. A body with mass half a kilogram is attached to the end of a string that is stretched 2 meters by the force of 100 newtons. The body is also attached to a dashpot that provides 1 newton of resistance for each meters per second of velocity. If the initial position is at 1 meters and the initial velocity is negative 5 meters per second, find the position function, its frequency, and pseudo period of the motion. Also, the time lag and the times of its first 4 passages through the equilibrium. Okay. I don't think we ever discussed time lag, but during the solution, I'll tell you what time lag is. It's also another important concept that comes up when you do electrical circuits. The LCR circuits have a very similar equation, and there the time lag is actually one of the essential things that you want to figure out. All right, so let's try to solve this. First, you have the master equation, mx double prime plus cx prime plus kx equals to external force. In this question, there's no external force. We do have the dashpot, the mass, and the k, so we should find them. What's the value of m?
5.
Yeah, 1/2 or 0.5. Okay. What about the value of c? It's 1 newtons per meters per square seconds, right? So it's 1. And to find k, you need to use f equal to kx, which says that you have 100 newtons is k equals to k times 2 meters. So k is equal to 50. Okay, and then external force is 0. So let's write down the equation you get. You get 1/2 x double prime plus x plus 50. X prime, by the way. X and no external force equal to 0. And then you get x of 0 equals to 1 and v of 0, which is x prime of 0, that's equal to negative 5. And we just have to solve this. Let's try to, yes?
Are we doing the negative for k?
Yeah, when we need to find the value of k, we can just neglect the signs. I mean, we can use the negative and then also say that when you're pulling it by 50 newtons, the spring force is actually countering that, so it's negative 100. Right? When you pull it by 100 newtons, the force of the spring is negative 100, and then x is positive 2, and you actually have a negative kx, and the negative and negative cancel, and you get the same value of k. But when you're just trying to find the value of k, you can just get rid of the minus signs and just plug in the values. Okay, now let's multiply by, first, now we have to solve this. First, write down the characteristic equation. 1/2 r squared plus r plus 50 equals to 0. And multiply by 2, because I don't like fractions. And you can solve this using quadratic formula, but I would rather solve this using completing the square. So what do? You take the half of 2, which is 1, r plus 1 squared. 1 squared is 1. 1 plus what gives you 100? 99. So that means your r value will be, you subtract 99 to the other side. Taking the square root of 99 gives you square root of 99i. And then plus or minus. And when this goes to the other side, it's negative 1. Now that means, what's the solution? X of t is C1 e to the negative 1t, this negative 1 becomes the exponential function, negative t cosine of square root of 99t plus c2 e to the negative t sine of square root of 99. Okay. And then now we plug in 0 to figure out the value of c1. X of 0 is 1, that was given. But since sine of 0 is 0, this one doesn't survive, and e to the 0th power is 1, cosine of 0 is 1. So the only thing that you get from the right side is c1, so we get c1 equal to 1. Then we have to use x prime of 0 equals to negative 5. To get that, we have to differentiate this. X prime of t is, you have to use the product rule. So if you differentiate the first one, it's negative c1 e to the negative t, cosine square root of 99t. And when you differentiate the cosine square root of 99t, that becomes negative sine. And then when you differentiate the inside function, square root of 99 appears as a coefficient. So we get and similarly you have to differentiate the second function, which will give you negative c2 e to the negative t sine square root of 99t, and then plus c2 times square root of 99 e to the negative t cosine square root of 99t. This time, if you plug in 0, whose value should be negative 5, that's what's given. X prime of 0 should be negative 5. But on the right side, all the terms with sines, they will disappear. Only the ones with cosines will appear. And using the fact that e to 0 is 1 and cosine 0 is 1, you get negative c1 plus c2 times square root of 99. And because I know that c1 is equal to 1, if I move this negative 1 to the other side, I get negative 4 equals to c2 times square root of 99. And that will give me c2 equals to negative 4 over square root of 99. Okay. So you plug these numbers back in, and we get x of t equals to e to the negative t cosine square root of 99 t, and then minus 4 over square root of 99 e to the negative t sine square root of 99t. Okay. Now to find the pseudo frequency or pseudo period, you have to put this into a single function. So let's do that. Again, we're trying to put this into c times e to the negative t times cosine omega t minus alpha, where omega is this number, square root of 99. Let's try to find the value of c. C is square root of 1 squared, because that's 1 here. And then the other number is 4 over square root of 99 with a minus. Doesn't matter because if you square a minus, it's plus. And 1 is 99 over 99. 4 squared is 16, so you have 99 plus 16 over 99 square root. And that's 115 on top, 99 at the bottom, and you just have square root. I don't think you can do much about that. I don't see any common factors top. Yeah, there's no common factor here, so you just have to leave it like that. Now for the alpha, we have to do tan inverse of 4 over square root of 99 minus divided by 1. And again, we can just pull the minus in front. And tan inverse of of 4 over square root of 99. And then you get the calculator again. Let's see. 5 take the square roots. Okay, and then I can take the tangent inverse. Okay, I get negative 0.3822 as your, yes?
For the second thing that you do with the angle, isn't it just negative tan, not negative tan inverse the second time?
Well, the function was negative.
No, this tan inverse is always the function that you need to use. This minus that was inside, you can pull it outside. Oh, did I not put the tan inverse in the previous one?
Yeah.
Ah, sorry, that was a mistake. I should have put the tan inverse. In both cases, I'm trying to do tan inverse. Thank you for correcting me. Okay, so this one is correct. The previous video that I recorded, that one should be just, instead of just tan, it should be tan inverse in both cases.
For alpha, is it supposed to be parentheses or like the absolute value sign after the inverse tan?
It's parentheses.
Okay.
Parentheses and tan inverse functions or sine inverse functions, the minus sign can be pulled out.
Okay, I just must have been.
For cosine inverses, you can't do that.
Okay.
Arc cosine, you can't.
So that's your name,
This is the phase angle. This is what we call the phase angle. So putting those back in, we have the solution of the system, which is square root of 115 over 99 e to the negative t. The omega we had was square root of 99 t, and then minus negative 0.3822. So once you have that, I forgot to put the cosine function. Sorry, it should be cosine function before. Let me erase this one. This should be inside the cosine function, so e to the negative t, square root of 115 over 9. Okay, so once you have this, because the amplitude has e to the negative t in front of the cosine, the amplitude actually will go down and down. Okay? Another way to explain this physically is that because you have friction, originally it used to be going back and forth, but then it slows down because of the friction, and eventually at some point later, it won't. You wouldn't see it vibrating because it's so tiny. Okay? So that's what you will see. And then another thing I want to say is, because the amplitude gets reduced, it's no longer a periodic function. So you can't say period of this function. It doesn't make sense. It's not a periodic function. Yes?
In the last answer, there was an e to the negative t in it. Was that because there was no drag?
So in the previous video that we recorded, there wasn't no e to the negative t because there was no friction in that problem.
Oh, okay.
There was no dash pipe. Okay. So in the case when you don't have any friction, it will just go back and forth internally. It will never become slower. Okay, so this is what you would get. So no longer you can talk about period. It doesn't exist because it's not a periodic function, but you can still say pseudo-period, which is defined maybe like the second time you come back to the equilibrium or something like that. Okay. Yeah. So I mean, pseudo-period is basically the period assuming that you didn't have this e to the negative t function. Okay. So therefore, the formula is still the same. T is equal to 2 pi over omega. So it's 2 pi divided by square root of 99. That's your period. And then,
No question.
Yes.
Where did you solve for omega? I didn't know that omega was.
Well, omega is when you put these two functions together, the square root of 99t that stays. Because the way we put these two functions to a single function is, I already went over that a few lectures ago, but basically the idea was to use the following formula: cosine omega t times cosine alpha plus sine omega t times sine alpha. This is actually the cosine sum formula. So this, if you put it into this form, if you put this into this form, if you can put the part of this formula into this form, then this can be written as cosine omega t minus alpha, just like that. Okay? So you can see that this omega will be still the same omega t. All right, so we have the function now and the pseudo period. Pseudo frequency will be the reciprocal of this. So we can say that pseudo frequency is square root of 99 over 2 pi. Yeah, but those, we need to say pseudo, PS, EU, DO should be in front to stress that this is not by no means a periodic function. Okay, but now here's the time lag thing. What is the time lag? Well, time lag is this. It's trying to explain what this is doing. Right? If you have this, it shifts something to the left or right, right? Because this is minus, it's going to be moving to the left. Okay? But the graph itself is not really moving exactly to this. In order to see how much it really moves, you have to switch this thing inside as square root of 99 t minus negative 0.3822 divided by square root of 99. And this number here, this much, is called the time lag, because it lags behind. But sometimes it might go ahead. It's not always the lagging. It might have a few frequencies going ahead. Okay. So that's the time lag. In pre-calculus, if you learned this in pre-calculus, you learned this as phase shift. So this one was called the phase angle, whereas this one was called the phase shift. So what is the formula for the phase shift or phase angle? I think usually they write out delta or something. The delta is alpha divided by the omega, the angular frequency. Okay? So you just, because that's what's happening here exactly, right? That whatever that was in front, that's dividing this alpha, the phase angle, right? Phase angle divided by the angular frequency is equal to the delta. So you have to do that. So let's see, time lag. Lag is, if you did the calculator, it's probably about negative 0.038.
It's just that second one. It's just the fractions it's handling.
Yeah. If you divide this by this, you will get that. Okay? 3.8 or 3.9. It's one of those. Okay? That'll be probably 3.8. Okay, and then the next thing that they are asking is, when does it come back to the equilibrium? Okay? It says find the first 4 times where it passes through the equilibrium. When does the cosine function become 0? Do you remember the graph of the cosine? Cosine is 2 pi, pi over 2, 3 pi over 2, and then it's like this. So at these times, the cosine becomes 0. That means when square root of 99t minus, actually minus is plus 0.3822 equals to pi over 2, 3 pi over 2, and the next time it comes back to 0 is 5 pi over 2, and then 7 pi over 2. At these places, when you solve it, you will get, you will figure out when it passes through. Now, let's just try to use Microsoft Excel to find the values. Okay. Okay. So we need pi over 2 equals pi over 2. Maybe it's not recognizing pi. Let's just do 3.141516 divided by 2. And then the next one is 3 times 3.1416 divided by 2. And the next one is 5 times 3.1416 divided by 2. And the next one is 7 times 3.1416 divided by, about 3 divided by 2. Okay, and then for each one of these, if I go back, I need to subtract. So here I have to subtract from both sides negative 0.3822, right? So I'm going to do that. So I'll just say equals whatever this is minus 0.3822. And Excel has this nice thing where you just do that, and does it for you. Okay, and then now you divide that by square root of 99, so it equals to this thing divided by SQRT of 99. And then that's what you get. To that. And these are the values. Okay. So you get these values. Oh, it's so small. So just let's move it over here. No? Let's move it here. Make it large, just like that. Okay. So the answers are when time is 0.11 seconds or 0.12 seconds after the initial time, and at 0.43 seconds, 0.75 seconds, and 1.0607 seconds. Those are the times where it will pass through the equilibrium. So I think initially you pulled it, right? And then you released it, and it went that way, right? So initially it's going to pass through the equilibrium this way at 0.12 seconds after release. It's going to go there and come back, and at 0.444 seconds it's going to pass through the equilibrium, and then like that. So those are four times where it hits there. Okay?